Hello everyone. Today is Matplotlib second class, and before that, let me know it's recording or not. Yeah, it's recording. So yeah. See, in the last class, what we did. Not this one. The basics of Matplotlib, how we can import Matplotlib, and what are the main functions, how to plot a graph, how to plot two axes, what are the markers and how we can align them, what is alpha and all things we did. So in today's class we are going to see, if you want to go for the in-depth of Matplotlib, you can go and visit this book, Visualization with Panda, this Python data science, and definitely it has around 10 or 12 chapters. And the important concept which we need to study exploratory data analysis or machine learning will be enough if we just cover these two videos and some hands-on project. And if you want to learn some new function or something, definitely we can do by just going this way. See, if you want to plot something, if you want something how to connect dots in Matplotlib, just type and search, or you can go for the user manual as well. So Matplotlib, if you type Matplotlib, yeah, see the last one. Okay, if you want to get reference sheet documentation, you can click anything and you can get that part. Okay, let's see for this one now. Yeah, say if you are going to plot scatter 1, scatter xy, and this size, colors, cmap, everything we will let you know by today. And this is how you can reach, and we will be just covering the basic and important parts, what to counter, p color mesh. So the basic thing we will be covering. Say if we started covering each and everything, so it will start being boring for you, and definitely you will not get the interest. So that much will be covered, which is needed to learn for machine learning. Okay, let's dive into the today's content. I wrote all the codes earlier only. See, the first thing how we import is like this: matplotlib.pyplot as plt, alias name is plt, and numpy is np. And I'll explain this third line of no code. Okay, what is legend? See, L is capital, right? In the last class I told about the legend, that is this part, how we can add name to the graphs. Okay, what we are plotting, how we can define, see, sine and cosine, these are called legends, right? Over here we give a border to it. Okay, that is frame on. Yeah, if we give frame on, it will give a border to the legend box. So in this video we are going to cover about the basics of how we can plot two graphs in this. See, we have subplot at the last also. Okay, see, basically whenever we are trying to plot, we got only one graph. Okay, let over here also one graph. For the histogram also, or for the error graph also, we are getting the same thing. Okay, error bars, sorry, basic error bars. This is the line graph. So how can we add two or more graphs in a singular graph, or how can we plot more than 2 or 3, 4, 5 graphs in a particular frame or something, you can say. So first there is a function known as subplot, where we have to define which row we want to assign the first graph, which column and which position, right? First row, second column, and over here this is for the first one, and for this also first row, second column and second position. Okay, we'll run this and we'll get something like, see, we are going to plot this as the first x-axis and this as the y-axis, and I will plot the our graph, right? Okay, what is the relation between both of them? The basic graph, right? And over here at 1 the value is 6, at 2 the value is 5, and 3 the value is 4. Yeah, see. Okay, so it is getting plotted, and we use title function to get the graph title. This is how you can adjust. See, if you do something over here, okay, if you do for the third or fourth, you can try it out. See, it is saying that okay, it should be less than and equal to number 2, right? Okay, the number of plots are 2 only, so it should be within that. So how we can, if you have only 2 things, and how we can arrange it to the third position? So it will be given error, right? And yeah, you can try with this number, change the number, and you'll get the something different meshy type. Okay, see, second row, second column, what we are getting, plot 1 and plot 2. If you do like this, if you want to shift to this, see how we are changing the size and all. No, okay, as per the dimension, see the first row, then the second row, first column, then the second column. So you can try with this and play. Okay, after this we are going to use the subplots again. This time what I am trying to say, okay, the last time when we are covering the legends now, over here, it was at the upper left, then we changed to the bottom middle, and again the color change, background change. The question was how to get it into the middle. The homework was to find the location. Again, it's your homework only. Do comment or something, or you can put it into WhatsApp group or Discord channel if you got the solution how to put this, okay, into the center. The question is, let's say over here we are having 2 legends, but we are having one more, this red line, right? We are having actually 4, 1, 2, 3 and 4. This sky blue, purple, again green and red. So purple and green is allocated, but sky blue and red is not allocated. If I want, okay, to allocate this also, I can just pass the whole list. So yeah, all the lines will be allocated over here. Okay, no issues. Over here I was passing like this now. Leave it for now. Okay, I have to run it again and again. Okay, so till now, okay, how we can plot, see how we can get one legend at above and one legend at bottom, or how we can distribute it. So this is the basic what we are doing. We are giving, okay, figure and axis is equal to plot.subplots. We are assigning this function to both of the variable name, and lines we are having a list. Okay, we have a list of lines in which I'll tell you what, okay, why we are not assigning something over here. Then we have style, this one. Again, we in yesterday class we discussed about the many styles, how you can plot dash, straight, dot dash, right, or some that bar type. Okay, in between we want some dot. So again, x numpy function, line space 0 to 10 divided in 1000 parts. Over here we are assigning the lines value. How? See, we have a function, mathematical function, we can say numpy into numpy of sin x, numpy of sin x. What we are passing the value x into x minus I. What is I? In the range of 4, right? Just for example 0, 1, 2, 3 multiplied with n numpy divided by 2. Okay, so it will give us this function, and what we are doing, we are just adding it to the last one. Okay, let's say if a line plus equal to states that line is equal to equal to lines plus axis dot plot this thing, and we are given the color is for black, and styles, what we have styles for different styles. For the first one, I is equal to 0, so the 0th index will be done. So line A will be dot something. Then if we want straight line particular line, so style 1, when it will come 0 after 1, so the style will be straight line, right? Yeah, it's correct. Then double this means dashed line. So when the I comes to second, the values also over here will be changed, and the sin x value will be calculated for the value for this value, not this value, and again added to the lines what we have earlier. Okay, so same thing. Then we are giving axis equal, means distribute axis into equal parts, and over here axis dot legends. See, we can call legends, but we want to distribute too, right? So first we are going to call from 0 and 1, right? For all, just go till 2. So line A and line B, we are giving the legend name. Okay, these are the line A and line B, and it's printing over here, right? But if I want to print something at bottom, what I called over here was we have to import one more function, that is legend. Over here from matplotlib.legend we have to import legend, and we can call it again axis for the axis part. Okay, this is called an artist function, where we are adding from our end. Okay, after, see, if you do 2 times of legend, no, if you no bhaiya, I will do one thing, I'll just copy it and I'll change the code like this. Okay, apart after 2, just do like this, put the colon. Okay, all after 2 will be line, instead of A we'll put C, and instead of B we'll put D. So the problem will be like legend only get accepted by the matplotlib function or plot function only once. Okay, so either it will overwrite or it will not consider, right? So to avoid this kind of problem, what we have, we have one function, that is add artist. From our end, if you want to add something from our end, we can pass it to this, and that will be added. Right over here we are assigning one more legend where we are passing the axes again, that subplot lines are 2 to 2 and 3. Right, we are having lines in 4 range 0 to 3, so 2 and 3 are passing the second line and the third line. Over here the location is lower right. Right, okay, so we are getting lower right. If you change to lower left, it will get into the lower left. See, we got into the lower left. Right, and we have to call this function ax.addArtist, and we have to pass this legend. This thing you can directly pass without assigning this variable over here. It will give you the same thing. And again plt.plot to plot the graph. So this was the one concept which was left in the chapter number 29. And after this we have customizing, say double I, customizing color bars. Right, customizing, see if spelling anywhere if you find my spelling wrong, do ignore it. Customizing color bars. See over here what we are doing, okay, see in the last class I told you about how many styles we have. So to find that we can directly put this code over here. It will give you how many styles we have in our system, or whatever you are using, PyCharm or NumPy or any VS Code or something. Where it went, dot available, plt plot.style.available. It will give you all the list of the styles which we have, which we can use. Styles are nothing but the background how we want. Right, so Cbun white version we are using, and for the X again line space NumPy, everyone is familiar. And over here I'm taking what we say variable multiplied by numpy.cos of x, and here I am converting all the values of the x, that is 1D array, into 2D column vector. Like I told you in the NumPy class, okay, that axis will be converted into, if it is in column it will be converted into the row and it will be multiplied. Right, so over here we are multiplying over, that's why. So if you do this plot.imshow, imshow doesn't do a big task, just it transfers the data, like it represents the data as an image. Whatever we data have in our I variable, it will be shown as the as in the form of image, that is image show of I data. So it will give an image, and plot.colorbar will give us a color, this color bar, right side one. Right, and if you do this, see what will happen. We got this graph, right? And how many color maps? See here we have only black and white. Is there any else we have? Yeah, you can type this command plt.colormaps. It will give you all the available. See, by default we have some known as Verdis. I can't spell it. Verdis. I'll show you over here. Somewhere you find, guys. It has 2-3 versions. Verdis R, Verdis something. Somewhere it will be there. See, if you want to change it, you can change it from your end. See, like over here in the next example I had changed. Okay, so these are the styles what we have. Right, by default it is Verdis. Yeah, see above third Verdis. See, what are this? These are nothing but the color map. It is like a set of color schemes what we can use to plot our graph. Right, see over here we are having black, little bit of gray and white. 3 color are being used on, this is the gray scale or black and white scale. So we as per this we have different types of color maps that are sequential or divergent or qualitative, and apart from this also we have some that we can call it as miscellaneous. So what will happen if you are having an order data, we have to mainly use or prefer to use sequential color maps. Some examples you can use like cool warm or something. No, cool warm is for diverging color maps. Okay, and you can go and check for this also. Okay, if you want to check types of color maps, you can type types of color maps. So based on your data, if it is let's say if it is categorical data or unordered data or order data, types of color maps and Matplotlib. Choosing color maps, yeah. Yeah, these all are sequential color maps. See, grays, purple, blues. Okay, these are the codes which you can use to get this color frame into your code. Right, these are the code name. You can just copy and paste it over here. sequential to again, this is diverging one. The diverging is mainly used for your central data when you have, let's say, you are comparing between two, like positive versus negative numbers, or some A versus B team or something like that. So at that time you can use diverging color maps. Some of the examples are this. And again, when we have cyclic, I don't know about this, but yeah, it's we start and end it to the same color. Okay, if we are starting and ending to the same color, we are known, it is known as cyclic maps. See, yeah, miscellaneous, I told, no, some of them are which right now are not in use, or rarely it is used. For example, whenever you are using, if your application is for some geographical task, let's say if you are mapping using the satellite data, so how you can map the terrain or something, for that you can use miscellaneous. For example, ocean is there, or some terrain you are mapping, so you can use to plot some graphical or scientific data. Right. So Gist Earth, Terrain, Gist Turn, GNU plot. See, I'm not aware of this much. Yeah, Jet is the common one which you can use. Ocean is definitely, if it is green, it means depth is too much. If it is white, so depth is low. So you can define it as per your own. Right. And qualitative is done, miscellaneous is done. Okay. Divergent color maps, it is for the central data, I told, for example, positive or negative. Or qualitative is mainly for your categorical data. Let's say if you have some paired data or some sets are there, if you want to, yeah, see over here, sets are there, if you want to compare it in between them, you can use this. Right. Okay, just type it and you do research by your end. Okay, again, converting one error, why I'm writing both. Okay, see over here, for the x-axis it's starting from 0, 200, 400, 600, 800, but for the y-axis 800, 600, 400, 200 and 0, the y-axis got inverted, right? And if you want to get it to back to the origin what it was, so you have just one command over here, that is called origin. The origin is, okay, for our graph it is 0 by 0, right? Everything 0 and 0 should add origin, that is 0. So if you put it lower, it will go over here. Otherwise, what im.show did is it inverts the axis of y-axis, right? So all the values will be inverted. See, our graph is also changed. First over here it's dark now, and over here it's gray, something white. Over here now it's white, and it's now here dark, right? And one more thing I'll tell you. Okay, see over here, if I want to put some marker, okay, I want, rather than being a dashed or like in a bar, I want it to be like a arrow above and arrow down. What I have to say, we have markers again, kind of marker we use to extend. Okay, if I want to extend, it is going somewhere or it will go down bottom, we have extend also, right? And somewhere I'll tell you, yeah, see over here there is no margin. Okay, this is the value. Okay, if you are spotting this color, or if you are spotting dark color, it will be nearly equal to 1, and if you are spotting exactly white color, it nearly equal to -1. So how you can differentiate between, or like if you want to convert, as of our in histogram, you can see below will be histogram. These are the beans, right? I told you that represents particular type of data or the values of data we have. So same way you can distribute, okay, how many beans you want, or how many lookup tables are there. Okay, this is one categorical by color, another categorical color. So if you want to categorize, we have one function called as LUT. Okay, so for that you have to call one more thing, that is our CMap function. Okay, so color mapping, I'll show you. Yeah, see over here the same question, plt.image. So I pass this and CMap. Okay, what I want, the color map. In color map, I want it to be distributed into 9 beans. You can assume it like beans. See, the data is now circulated. Particular bean is this square, or like this square is denoting one kind of data, particular type of data, this type of data. So if you change, right now it's 9 now. See, if you do counting 1, 2, 3, 4, 5, 6, 7, 8, 9. So this color palette is distributed in 9 beans. If you do it to 3, see 1, 2 and 3, the particular type of data you can assume it like this, gray, white and black, right? So you can change and you can play again. For 6 it looks like this. The more you increase, the more beans you will get. See, I don't think, okay. See, for the 10 complexity increases, let's say try with 100, what will happen? Yeah, see, so it can't plot 100. Let's try for 70 again. So you can try, right? And origin is equal to low, I told you. Extend, I told. What else? The above code, yeah, nothing over here. Okay, if you want to know this, this is nothing but, see, I'm just going to brief you, not going to teach you. Okay, okay, you must learn this. It's not necessary. It's just a way how you can check. Okay, okay, if there is a color scale right now, it's black. No, I done for blue also. I'll show you that blue one. Where it went? Okay, let's say if you want something color, you just change the C map to set color map. No, over here we are doing, let's take a color, let's say, is there any blue? Okay, control F, blue. Blues is there, BLUES. Okay, right. Done. Okay, just pass over here, not in this, you can directly pass over here. See, CMap takes two parameter, right? One is your this cm dot get CMap is nothing but color map dot get color map. We have two parameter. First is what we want. So by default it is what was the name? Weirdest. So it is black and white grayscale. If you want to change the name, you just have to pass the name is equal to. See, the get CMap function only takes two parameters. So if you put the name directly, it's not a big issue. You can put it, paste the name, put shift enter. You got the blues, right? And I'll change to 7. You'll get more clarity, right? So you can change the color. You can change with the all the styles what we have. See, if your first earth R is there, anything, you can just go copy paste. See, we got. So every color has a different application, and that different application I told you, it was in the 4 categorical values mainly. That is sequential color maps, divergent color maps, qualitative color maps, and miscellaneous one. Okay, so yeah, so everyone has its own function. You can go and check over this side. And again, over this code, I don't know the line number. In this line code, what we are doing, we are plotting our graphs, and we are just changing the color of the original color. Let's say if we are having the bluish to reddish color palette, and it's like rainbow, no? So WebGear, what will be the grayscale? So how we can do? So it's nothing but we are defining over two again a function. You will get this it is directly copy pasted and added some comments from the book only. So in the book you will get the why we are doing this. Sorry. So you guys find it out. Over here. See what it is doing, no? It's just returning a grayscale version of the given color map, right? So whatever we will pass over here, see here we are passing the jet, no? I told you jet is there. If you pass blue, so it will take the blue palette and it will convert it into the grayscale, right? So if you are interested, you can read the code. It's nothing but changing the weights of according to this. We are changing the colors of what we have. Luminance is nothing but the light intensity. So black is nothing but how much light is going to a particular part. If it is the light is too much, so it will be bright enough, and the light is too less, that will be regarded towards black in color, right? Okay, it will be a little bit complex if you go from like this, but yeah, it's fine. If you want, if you're interested, you can go like this. X-tick and Y-ticks are nothing but whenever we are plotting some graph, no, let's say we'll come above a little bit, some histogram, let's say for histogram. I think I didn't tell you guys this. See, X-ticks are nothing but if you over here you can see it's at the center, no, -3 it's at center. If you want it to be at left, you just assign the position left. If you want it to be the right, you just assign. See, it is randomly assigned by the Matplotlib, this -3 to 3. If you want from your particular end, if you want the tick, how it tick should look like, you can do that also. Color you can change, you can do anything if you want. So that is X-tick and Y-ticks over here. right? And that's it. After this, yeah, again, word is, or if I'm spelling it, you just, we are just convert. This is the by default. Whenever we plot the graph, no, it will come like this, and we are just getting the black grayscale of this. Again, grayscale of RDBU. Okay, here some dual colors, color limits and extension. Oh, the extension part I already told. Then color bars for the blues, it's blues. See, blues and six is nothing but a kind of bean, you can imagine. This part we will do in C1 if we are interested. Okay, it's right now it is nothing. It's not telling a big part. It's just telling okay, okay, every image whenever we are going for the image analysis, no, or deep learning or something. So at that time, every image is just converted into the pixels. As you can see, whenever you have seen any something for images or something, you have seen it like pixels, right? So the pixels might be gray, white, and see it will be colors, right? So every palette or every pixel has its own color, which distinguishes and which completely combinedly makes a image, right? If we zoom out, we can easily say it's a 3 or it's a 4 or it's a 5 or something. See, right now we can't see the pixels easily, so but we can identify 0 1 2 3 4 5 0 1 2 3 4 5, again the repetition. So but as we zoom it, we can see the pixelated, no, we call it like image quality is getting reduced, is nothing but pixels, arrangement of pixels, right? Over 64 we consider each digit to be plotting line, and 64, yeah, see all the values, no, what is the color values, this is how system identifies itself. Okay, okay, uh, just a second, I'm getting a call, just a second. Yeah, so over here, how a computer can understand this is 3 or this is 3. See, there are many ways of writing 3, right? Or I think so it is a copy only. No, it's different. So what are the different ways of writing 3 or 5? See over here, 5 is, there is more slant, this is more curved. So what computer do it? It stores the colors of everything in a palette of what are the margins and all, and it compares with the original one. Okay, so the more accuracy or the more precision it will get with somebody. See, like for the 5 it can be 6, or it for 1 it can be look like 4, or 4 can look like 7. It is a good example over here, but if you use somebody's handwriting, no, for many people it's look like someone 5 is equal to 3 or something. So it just uses the pixelated density. Okay, which one is the more dense, what is the color density. So that's why we need to convert every color into black and white, so that computer can understand, right? Dimensity reduction techniques such as manifold learning to reduce the dimensity of the data, maintain the resolution. Okay, see, multiple subplots, I was trying to tell you, okay, whenever we want to plot some graphs within a graph, and a multiple graph we want, like here we are plotting two graphs, that is the sine wave and again cos wave we are having. So how we can do like this? So to get this, we have just a second, yeah, over here I think so, yeah, this is the color map. If you are plotting one axis, again in axis we are giving okay, what is this? See, 0.65 I am giving, this is nothing but your width and part. See, this is the length. Okay, from the 0.65% from the left, 0.65 from the right, what is should be the width and all. So you get the parameters and you plot it. Okay, the second one, how it will look like. See, over here we are telling no, 0.65 from the left. So from here the 0.65%, that is nothing but 65%, right? 0.65, you can call it 65% left from the left, 0.65 from the bottom, 0.2 from the, that is the distance from over here to right, and here to top, bottom to top, right? That is width, you can say. You will get two of the graphs. Over here we'll get the main thing what we saw over this in the book. We are, see, plot figure is nothing but, this is again one new function. Whenever we want a blank chart, right, a blank graph paper, we used to call plot.figure. And in first axis we are telling okay, add axis, this one 0.148584, right? And tick, x tick labels, see over here we are giving nothing, right? We are passing nothing x labels for the figure 1. The above one is the figure 1 and below one is the figure 2. So what does this do is it gives okay bhai, do one thing. Whenever we don't pass anything in this, no, it will hide all the elements. It will hide all the x ticks, or x values, you can say, or x values, right? And while limit is telling ki okay, go from -1.2 till 1.2. Same for the axis second. What we have, axis second is nothing but for the this one, yeah, figure 0.1, 0.1. It's again nothing but 10, 0.1 is 10%. See, if you multiply 1 into 10 and 5 into 10, 8 into 10, 4 into 10, you will get the percentage, right? So 0.1%, 0.1 into 10 is 10%. Sorry, into 100, sorry, into 100. You'll get 10%, that is 10% from the left. 0.5 means 50% above the height, and 0.8 means okay, 80% of the width I'm covering, and again 0.4 of the width over here I'm covering, right? So same for the axis 2, 0.8 and 0.4 of the width, and again 0.1, that is 10% from the bottom, 10%, this is the 50%, this line, and this is 10% from the left. Okay, if you want to check, okay, what will happen if I put 0.2, just put it like this, see it is getting shifted, right? And if you do 0.6 over here, see what will happen, it will overlap, you got it? If you put 0.5, that is 50% above the x-axis, the bottom, you can say. Let's say 0.1 only, right? And if you put 0.8, if you change to 0.6, see what will happen, it will shrink, right? This width will shrink. And if you change 0.4 to 0.2, the length of this graph will shrink. So you got the concept, right? And y limit again from -1.2 to positive of 1.2. Again, we are giving the x bar, okay, divide the values of the x-axis and line space 0 to 10. Okay, by default, if you are getting, see, like 0, 10, 20, 30, 40, 50. So Matplot, what will do now? Okay, it will change your graph parameter as per the data what we have, right? So this is a feature, you can say. Axis 1 plot np.sin x. So we got the first as sin x, and axis.2.plot is, cos x, right? This is the main concept again, and let me check if I'm forgetting something. Yeah, I'm forgetting one more thing over here. See, if you put c limit, a function is there. If you put c limit now, plt dot c limit, and then over here if you pass the values -1 to 1, say what it will do, set the color limits of the current image. It will just okay, what should be the minimum and what should be the maximum values of the or the color scaling. You just pass it, okay, my color should be scaled between -1 to 1. See, you are getting the -1 to 1. It will not go beyond over there. That time I was telling no, it will go till 1. So at that time I didn't notice that c limit is not there. So it will go till 1 maximum, and minimum is -1, right? No colors above this will be used. So again, if white is there, see right now it's fine. But if we have some color palette like cool warm or magma or inferno or plasma, something like that, so you can use and try this. Or when we have some like I showed in the book, no, this one, let's say if we have a WebGear, if you want, say it can be 1 or -1 for the jet will be over here for blue or red. So you can try and check, right? Okay, now one of the most common type is we are left with the pie chart, and apart from this, you will right now what you have learned or what we have taught you is the basics of the machine learning in respect of data analysis using Matplotlib. So this will be more than enough if you know, and whenever after this we are going to do Matplotlib some projects, in that I'll explain some new functions if possible, or else after this we have exploratory data analysis when we are going to prepare the basics of the data or how it going to train the model, like what are the main things we should take in mind while preparing the model. So if some new functions are there, definitely we'll introduce over there. Some like heat map is there. Heat map is a concept where we are going to plot the values of our numerical data into colors, right? So you can say that it's a data visualization technique that used to represent numerical data using colors, or you can get the patterns, you can get the correlations, or variations of the data. See, whenever you saw over here, if you get, okay, see, it is going too much brighter. Yellow is going too much brighter, and purple over here or dark blue is there. So it is getting light, darker and darker, which means that it is having some lower values. Whenever we are going to plot some our features in the data analysis, or if you want to compare two of the entity with each other, at that time this kinds of stuff comes into place. Okay, higher values, what does it means? If it is giving me the means at most red in color, and it is giving me at most darkest blue in color, so what does it mean? It is less correlated, this means highly correlated or something like that. At that time we'll teach. And where we can use it, definitely machine learning to find the correlation between some matrices or some datas. And if you are using OpenCV, that is computer vision, so at that time also you can find computer doesn't understands color, the computer understands is black and white, right? So it converts all the color into RGB into black and white only. Then if you're going to learn about some brain or what we say medical imagining part, no, for the brain analysis or how brain is working, so at that time this colors palettes work a lot. Okay. Or mostly, see, if I am going on some website or let's say Instagram or something, so what I am doing the most, if I am scrolling the most, or what are the main thing or which button I am clicking. See, let's say if I am visiting 5 websites per day that are all social media, so what I'm opening the most is that messages section, or is it some notification section. So for example, meta have many platforms, so it can collect data from different of the websites of his own website, and can predict okay, this person is interested towards more in chatting as compared to watching reels, or this person is more interested to watch reels as compared to chatting, or this person is more interested in stalking somebody. So it will show you the content as per that. Okay, so this is another what we say, another place where heat map is used. And this is the main concept what I thought of to tell you guys till now. Definitely we covered a lot of part. Sorry for this. I think so, yeah, most part is done. This pie chart part is only left. So if we have an import, if we are doing import matplotlib pyplot as plt, and we want okay, we have some data and want it to be distributed like a pie chart, so how we can do? Again, we just have to pass what are the values or what are the percentage of the data we have, right? Runtime disconnected. Okay, no issues. See, for the size what we have 30, 20, 25, 15 or 10 means what are the quantities. Let's say if we want to vote for the some languages, Python, Java, C++ or JavaScript, so what are the votes? The 40 for the Python, 30 for the Java, 20 for the C++. For JavaScript, let's say for 10, or for the Java it can be 1. You just increase over here, you just type Java. So okay, oh, Java is already there, no? Just change it to 1. Why do we need to add extra entry? Right. And okay, over here I'll tell you. So what are size you got, what are labels means which label is, so you have to write it particularly to match the index for the 0th and 0th in this, both 0th element in this list of sizes must be mapped with the 0 index in the labels, right? Item in the label. So over here AI 30 value will be mapped with AI, 20 value will map with ML, 25 will be data science, 15 cloud, 10 cybersecurity, right? And what color you want, if you want color like blue, green, red, or you can change this order definitely. So the first thing of every index will be mapped to each other, then 20 ml green, 25 data science red. So this is how it is mapped. And yeah, plot size if you want to check, okay, if you want to, sorry, not size, plot pi, so you have to first give the size. You can change this label, it's not compulsory. Whenever you are telling no, okay, labels are equal to labels, so you can do anyway, like you can do this at first. Just over here you have to pass, okay, what are size equal to sizes, so labels is equal to labels, colors is colors. Auto percentage means ki, okay, how much percentage this data is covering, so how much, like till what decimal it should include the points, right? And start angle is nothing but if you are not comfortable in watching like this way, you can change the color, change the orientation. Say if you want to 120 degree, change it to 120 degree. Now the, see right now I'm not more what say क्या कहते हैं, adapted to this way of watching, or it can change to data, right? For my convenience it's fine, like this way is fine. If I want to change more like the same way, put it to 30. Now it's cybersecurity shifted towards this way, right? So you can plot it like this. If you want to give the title, give title like this, tech field distribution, then show the chart, plot dot show, it will show you the pie chart, right? I'm just doing fast because nothing left. No, you can understand basic things. Import, same thing I'm doing. Size is equal to Python 40, Java 1, and this. Explode doesn't, explode is one more category. When you want some shades, no, over here, or like if you want to, not shades, if you want to make it apart from the rest of them, like say Python is just picked outside of all of the pie, like slice. So you have to tell, okay, how much you want to explode, or like if you want to get out the slice out of the whole pie, you can just mention if 0.1 means it will be slightly away. If you put 0.3, it will give you a little bit more far, right? As you can see now. And see, I should change back to 30 only, so that will be more easy to visualize. Yeah, and explode 0.3, so it is more distance. If you want to, okay, I want C++ and Python apart, where is C++ at the last, so 0.3, put 0.3 again, so both will be apart, right? And colors you can mention. Plot figure size 6x6. If you want to change the size, you can just change, okay, I want basic, don't mention it. If you want to matplot to do it by automatically, don't mention the figure size. Then plot.py, we are just again passing the sizes, labels, colors. See, auto PCT, I told you how much percentage. If you want to change, or if you don't want, just remove this, so it will give you some extra numbers. But to look good, pretty, we can change this. Starting I told, explode I told. Shadow is equal to true means it will be show a projection of shadow of your data, right? So if you put it true, you will get a shadow like this. If you just remove it, so it is by default it is false, so you'll get the basic pie chart, right? And again, title, programming language popularity, plt.show will show the pie chart. So this is the basic thing about the Matplotlib, basic or intermediate level thing. इससे ज़्यादा नहीं पूछेगा. And if you want to more learn about this, okay, how if I want to plot 6 of the graphs, again you can go over chapter 31. Over here you can watch this code. Okay, how I can plot 6 of the graphs over here of different coordinates, 236, 235, 234, 231, 232, and 233, right? So yeah, try this by your own hand, right? That's it. This is the last most important point, and rest of them is not needed right now. You don't need this type of graph. See, it's not worth it to teach you guys this extra stuffs. Not worth it in the sense you are not going to utilize it by the BTech end, right? So it's not worth it. That's it. And again, we are not going to work under something company for this project or something. So at that time we need, okay, if you want to make some graphical in your chart, you can make. But yeah, apart from this, everything is fine. Again, C1 is needed to teach this, but the ticks are nothing but where you want the ticks, right? Yeah, this way our yeah, I taught this also, how you can change the colors and all. Graphs, 3D projection we'll do in C1 time, okay? And I told you I will not do because it's not needed. So yeah, it's fine. Whenever needed, I will teach you. Then again, visualization with C1, yeah. So the whole chapter is covered of the Matplotlib. Yeah, thank you guys. The video will be uploaded soon, or like you are watching this because the video is uploaded. Okay, thank you.